Podman Studio.
The universe is everything. It includes all of space, and all the matter and energy that space contains. It even includes time itself, and of course, it includes you. Earth and the Moon are part of the universe, as are the other planets, and there are many dozens of moons. Along with asteroids and comets, the planets orbit the Sun. The Sun is one among hundreds of billions of stars in the Milky Way galaxy, and most of those stars have their own planets, known as exoplanets. And in today's video, we will bring you in the deep space cosmic bodies that the scientists by our advanced technology, yet, had been seen and observed, in the outer space. Galaxy.
A galaxy is a huge collection of gas, dust, and of stars and their solar systems. A galaxy is held together by gravity. Our galaxy, the Milky Way, also has a massive black hole in the middle. When you look up at stars in the night sky, you're seeing other stars in the Milky Way. If it's really dark, far away from lights from cities and houses, you can even see the dusty bands of the Milky Way stretch across the sky. There are many galaxies besides ours, though. There are so many, we can't even count them all yet. The Hubble Space Telescope looked at a small patch of space for 12 days and found 10,000 galaxies, of all sizes, shapes, and colors. Some scientists think there could be as many as 100 billion galaxies in the universe, or more. Some galaxies are spiral-shaped like ours. They have curved arms that make it look like a pinwheel. Other galaxies are smooth and oval-shaped. They're called elliptical galaxies. And there are also galaxies that aren't spirals or ovals. They have irregular shapes and look like blobs. The light that we see from each of these galaxies comes from the stars inside it.
Nebula.
A nebula is an interstellar cloud of dust, hydrogen, helium and other ionized gases. Originally, the term was used to describe any diffuse astronomical object, including galaxies beyond the Milky Way. There are a variety of formation mechanisms for the different types of nebula. Some nebula form from gas that is already in the interstellar medium, while others are produced by stars. Examples of the former case are giant molecular clouds, the coldest, densest phase of interstellar gas, which can form by the cooling and condensation of more diffuse gas. Examples of the latter case are planetary nebula formed from material shed by a star in late stages of its stellar evolution. Star-forming regions are a class of emission nebula, associated with giant molecular clouds. Other nebulae form as the result of supernova explosions, the death throes of massive, short-lived stars. The materials thrown off from the supernova explosion are then ionized by the energy and the compact object that its core produces. One of the best examples of this is the Crab Nebula, in Taurus constellation. Still other nebulae form as planetary nebulae. This is the final stage of a low-mass star's life, like our Earth star, the Sun.
Supernova.
A supernova is the biggest explosion that humans have ever seen. Each blast is the extremely bright, super powerful explosion of a star. One type of supernova is caused by the last hurrah of a dying massive star. This happens when a star at least 5 times the mass of our Sun goes out with a fantastic bang. Massive stars burn huge amounts of nuclear fuel at their cores, or centers. This produces tons of energy, so the center gets very hot. Heat generates pressure, and the pressure created by a star's nuclear burning also keeps that star from collapsing. When a massive star runs out of fuel, it cools off. This causes the pressure to drop. Gravity wins out, and the star suddenly collapses. Astronomers believe that about 2 or 3 supernovas occur each century in galaxies, like our own Milky Way. Because the universe contains so many galaxies, astronomers observe a few hundred supernovas per year outside our galaxy. Space dust blocks our view of most of the supernovas within the Milky Way.
Pulsars.
A pulsar is a highly magnetized rotating compact star that emits beams of electromagnetic radiation out of its magnetic poles. This radiation can be observed only when a beam of emission is pointing toward Earth, and is responsible for the pulsed appearance of emission. Pulsars are spherical compact objects that are about the size of a large city, but contain more mass than the Sun. Scientists are using pulsars to study extreme states of matter, search for planets beyond Earth's solar system, and measure cosmic distances. Pulsars also could help scientists find gravitational waves, which could point the way to energetic cosmic events, like collisions between supermassive black holes. Discovered in 1967, pulsars are fascinating members of the cosmic community.
Quasar, or quasi-stellar.
Quasar, an astronomical object of very high luminosity found in the centers of some galaxies and powered by gas spiraling at high velocity into an extremely large black hole. The brightest quasars can outshine all of the stars in the galaxies in which they reside, which makes them visible even at distances of billions of light years. Quasars are among the most distant and luminous objects known. First identified during the 1950s as sources of radio wave emission of unknown physical origin, and when identified in photographic images at visible wavelengths, they resemble faint, star-like points of light. High-resolution images of quasars, particularly from the Hubble Space Telescope, have demonstrated that quasars occur in the centers of galaxies, and that some host galaxies are strongly interacting or merging galaxies.
Blazars.
A blazar is an active galactic nucleus with a relativistic jet directed very nearly towards an observer. Relativistic beaming of electromagnetic radiation from the jet makes blazars appear much brighter than they would be if the jet were pointed in a direction away from Earth. Blazars, like all active galactic nuclei or AGN, are thought to be ultimately powered by material falling onto a supermassive black hole at the center of the host galaxy. Gas, dust and the occasional star are captured and spiral into this central black hole, creating a hot accretion disk which generates enormous amounts of energy in the form of photons, electrons, positrons and other elementary particles.
Black hole.
A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes. They are invisible. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than other stars. In 1915, Albert Einstein developed his theory of general relativity, having earlier shown that gravity does influence light's motion. Only a few months later, a scientist found a solution to the Einstein field equations. The first modern solution of general relativity that would characterize a black hole was found by Carl Schwarzschild in 1916, although its interpretation as a region of space from which nothing can escape was first published by David Finkelstein in 1958. Black holes were long considered a mathematical curiosity. It was not until the 1960s that theoretical work showed they were a generic prediction of general relativity. The discovery of neutron stars by Jocelyn Bell Burnell in 1967 sparked interest in gravitationally collapsed compact objects as a possible astrophysical reality. Black holes do not go around in space eating stars, moons and planets. Earth will not fall into a black hole, because no black hole is close enough to the solar system for Earth to do that. Even if a black hole the same mass As the Sun were to take the place of the Sun, Earth still would not fall in. The black hole would have the same gravity as the Sun. Earth and the other planets would orbit the black hole as they orbit the Sun now.
Some 15 billion years ago the universe emerged from a hot, dense sea of matter and energy. As the cosmos expanded and cooled, it spawned galaxies, stars, planets and life.
Podemon Studio.
And that's all for now. Thank you for watching. Please subscribe.